Most people are familiar with this word, but many are not very clear about what melatonin actually is, what it does, where it comes from, and how it takes part in sleep. Next comes the factor in modern life that most easily interferes with melatonin: light. Welcome back to DeepSleep Health Lab. When we talk about sleep, there is one word we hear very often: melatonin. Most people are familiar with this word, but many are not very clear about what melatonin actually is, what it does, where it comes from, and how it takes part in sleep. In this episode, we will follow these questions one by one and explain melatonin clearly. Melatonin is a hormone produced by the human body itself. A hormone can be understood as a chemical signal that carries information inside the body. The core message carried by melatonin is this: the outside world has entered nighttime, and the body should gradually shift from daytime mode into nighttime mode. So, melatonin is very much like an internal timekeeper inside the body. When the sky becomes dark, it sends a nighttime signal to the brain and the body. After that, activities that maintain wakefulness gradually decrease. The body begins to release heat. Core body temperature slowly falls. The person becomes more likely to calm down, and sleepiness gradually increases. Here, we need to pay attention to one point. Whether a person can fall asleep is usually decided by two forces working together. The first force is sleep pressure. The longer a person stays awake, the stronger the sleep pressure becomes. The second force is the biological clock. It decides what time of day the body is suited for wakefulness and what time of day it is suited for sleep. Melatonin participates in the second system. It helps the body confirm the biological meaning of day and night. For example, if a person sleeps until 6 o'clock in the evening and only then wakes up, then at 10 o'clock that night, even if melatonin has already started to rise, that person may still not feel sleepy. This is because sleep pressure is not strong enough. So, stable sleep requires both the correct timing signal and enough sleep pressure. So, what exactly does melatonin do? Its most central function is to help the human body maintain the circadian rhythm. Through long-term human evolution, many functions inside the body have come to change in roughly 24-hour cycles. Body temperature, blood pressure, hormone secretion, digestive activity, alertness, and sleepiness all have their own working rhythms. The nighttime signal sent by melatonin helps these systems enter a state that is suitable for rest at the right time. This transition does not happen suddenly. It is more like a city entering nighttime. The lights in office buildings go out one after another. Traffic on the roads gradually decreases. Stores begin to close. The whole city slowly becomes quiet. Melatonin is involved in this kind of gradual transition process. Next, let's look at where melatonin is produced and how its signal is sent out. Let's first look at this first figure. Melatonin comes from a very small structure deep inside the brain. In the figure, it is the orange point. This structure is called the pineal gland. The biological clock center in the brain, shown as the blue point in the figure, is called the suprachiasmatic nucleus, or SCN. The SCN helps decide when the pineal gland should produce melatonin and how much melatonin should be produced. Please pause here for a moment and look at the relationship in the figure. The pineal gland is the main source of melatonin, but it does not work alone. It receives timing instructions from the brain's master circadian clock. In other words, the pineal gland is like the factory, while the SCN is more like the scheduling center that tells the factory when to start production and when to slow down. The second figure gives us a more direct view of how melatonin is formed and how its working pathway moves through the body. The eyes are like light sensors. After light enters the eyes, one part of the information helps us see objects clearly. Another part of the information travels along neural pathways to the suprachiasmatic nucleus, so the brain can judge whether it is daytime or nighttime. When light is strong during the day, the suprachiasmatic nucleus suppresses melatonin production. When the environment becomes dark, the suprachiasmatic nucleus signals the pineal gland to increase the synthesis and secretion of melatonin. After melatonin produced by the pineal gland enters the bloodstream, it travels with the blood to many tissues in the brain and body. Then it binds to melatonin receptors on the surface of cells. Two important types of receptors are called MT1 and MT2. In simple terms, MT1 helps the body enter a state that is suitable for sleep. MT2 helps calibrate the biological clock so that sleep timing remains aligned with the day-night changes in the outside world. In this way, a complete signal loop is formed. The eyes sense light. The suprachiasmatic nucleus, which is often described as the biological clock, judges the time. The pineal gland secretes melatonin. Then melatonin carries the message of nighttime through the bloodstream to the brain and the body, helping different systems enter nighttime mode together. It does not simply stimulate one single organ. Instead, it coordinates timing across multiple systems. So, at what time of day is melatonin produced? Under a normal circadian rhythm, melatonin levels are very low during the day. After evening arrives, as the environment becomes darker, melatonin begins to rise. This rise usually appears about 2 to 3 hours before a person's usual bedtime. During the night, melatonin stays at a relatively high level. Then, as morning approaches, it gradually falls again. The exact timing varies from person to person. Melatonin does not have one fixed start time for everyone. People who are used to going to bed early and waking up early often have an earlier melatonin rise. People who sleep late often have a later melatonin rise. Season, age, light exposure, work schedule, and daily routine can all affect its rhythm. Next comes the factor in modern life that most easily interferes with melatonin: light. The light-sensitive cells in the human eye are especially sensitive to short wavelength light. Please note, short wavelength light here mainly refers to blue light. The wavelength of blue light is around 460 nanometers. Experiments have shown that blue light can suppress melatonin by roughly twice as much as green light. In other words, longer wavelength light, such as orange or red light, usually produces less suppression of melatonin. So, of course, light can also strongly suppress melatonin if it is too bright, too close to the eyes, shining directly into the eyes, or present for too long. This is why we should try to avoid looking at a phone for a long time before sleep. It is not only because the phone has blue light, it is also because the screen is very close to the eyes. The use time is often long, and the brain stays excited while we are reading information. If you really have to look at your phone, you can change the screen to a warmer color and turn on night mode. This can reduce part of the short wavelength blue light. More importantly, lower the overall brightness of the screen, shorten the time of use, and avoid placing a bright screen directly in front of your eyes in a dark room. So, how should we protect the rhythm of our own melatonin production? First, get outdoor natural light as early as possible after waking up. Outdoor light is usually much brighter than ordinary indoor light. Even on a cloudy day, it often provides a clearer daytime signal to the biological clock. You do not need to stare at the sun. Just let natural light enter your eyes normally. Second, try to keep a stable wake-up time. If your wake-up time changes repeatedly every day, it becomes difficult for the body to establish a stable circadian rhythm. Instead of forcing yourself to fall asleep at exactly the same time every night, it is often better to first stabilize your wake-up time. Third, 1 to 2 hours before bed, gradually reduce the brightness of your environment. You can turn off one bright ceiling light and use warmer lighting with lower brightness that does not shine directly into your eyes. At the same time, lower the brightness of your computer and phone screens and reduce long periods of close-range use. Let the light stimulation received by the eyes gradually decrease. Fourth, keep the bedroom as dark as possible during sleep. Turn off unnecessary lights and glowing devices. If you need to get up during the night, use warm light with low brightness and avoid shining it directly into your eyes. Finally, let's summarize today's episode. Melatonin is a hormone produced by the human body itself. The eyes sense external light. The biological clock judges the time. The pineal gland produces melatonin. Then melatonin carries the message that night has arrived through the bloodstream to the brain and the body. It helps different systems enter nighttime mode and helps our sleep timing stay synchronized with the external cycle of day and night. The key to protecting the rhythm of melatonin is not to chase a fixed number. The real key is to help the body clearly distinguish day from night every day. Get enough light and activity during the day. Gradually reduce brightness in the evening, and keep the sleeping environment dark during sleep. What other sleep questions are you interested in? Feel free to tell us in the comments. If you believe this episode is helpful to you and to others, please like, subscribe, and share. As always, we will continue to focus on your sleep health.